I'm Stephen Foskett, the organizer of Tech Field Day, and we're here in San Francisco at Intel Cloud Day. We've been listening to the presentations and announcements and so on from Intel, but we've got a group of independent storage experts here to react to what they've heard and talk about some various interesting concepts in the storage industry. Let's start by introducing ourselves, and then I'll introduce our first topic.
Hi, my name is Matt Leib. I'm an enterprise architect for Onyx. I blog on Virtually Tied to My Desktop, and I tweet at MBLEIB.
W. Curtis Preston, aka Mr. Backup. That's my specialty. I write for Storage Switzerland, and my Twitter handle is WC Preston.
I'm John Obeto. I am CEO and Chief Technology Officer for LogicWorks. I blog on SMBs and the mid-market at absolutely.windows.com.
I'm Ray Lucchese, Silverton Consulting storage analyst firm, also on Twitter at Ray Lucchese, and co-host of the Graybeards on Storage blog with my friend Howard here. And I also blog at rayonstorage.com.
I'm Howard Marks, also a storage industry analyst at deepstorage.net, and I blog at networkcomputing.com. On the Twitters, I'm at deepstoragenet, but as Ray said, Graybeards on Storage is what we do best.
Hi, I'm Chris Wall. I'm the tech evangelist at Rubrik. I blog at wallnetwork.com. I do a podcast called Datanauts, and you can find me on the Twitters at Chris Wall.
Very good. So let's kick it off with the elephant in the room. Last year, Intel announced that they were going to be releasing with Micron a new storage technology, 3D XPoint. Even before that, though, there's been a lot of talk about NVDIMM, in other words, non-volatile memory. This has been very, very confusing for a lot of people in the industry. Even some people at this table have been confused by exactly what this stuff is all about. So what is this stuff all about, and what progress has Intel made here at Intel Cloud Day? Who wants to kick it off with a little bit of a description about what we mean by NVDIMM and 3D XPoint?
I'll start with NVDIMM. So today there's a product that's semi-standardized that uses DRAM like a regular DIMM and has a capacitor and a power fail circuit so that when the server loses power, there's enough juice in the DIMM itself to dump the memory to the flash on the DIMM. They range up to about 8 or 16 gigabytes. They cost about 3 times what regular DRAM does, but they're great for a write cache in a storage system. And the big change this week is that Intel has been driving an effort to standardize how you address those DIMMs and do things like turn them off at boot time so that when the power comes back, the data is still safe. And HP has put them in their new Gen 9 servers. So that technology, which has been limited to the people who build storage appliances, is now available to the people who roll their own storage systems. And I think, when companies like SpringPath and Maxta and Nexenta take advantage of that, all of a sudden their technology becomes much more competitive with the guys that do appliances.
You also mentioned earlier Windows support.
Yeah, Microsoft at Build, and I don't have any details. I just saw a tweet.
Yeah, that was this week, yeah.
Yeah, it was today.
Down the road.
Announced that there's going to be Windows support for NVDIMMs. And if you look at storage spaces, then that means that now, instead of having to write data to an SSD or a disk, Windows can act when it hits the NVDIMM and cut down the application latency. There's a lot to see about how well they do it, but it's really exciting for the whole roll your own environment.
And to extend that, the BIOS announcement, what you elucidated earlier was that the advent of 3D XPoint would use the same standard on the BIOS on the motherboard to support this next generation of where we are today with NVDIMM.
Right.
And 3D XPoint, I think, is really exciting.
Well, 3D XPoint means that NVDIMM isn't limited to 8 or 16 gigabytes, that now that can be 128 or 256 gigabyte DIMM. And now that
and
write
again,
buffer
non-volatile.
Right. And that write cache can be much bigger. And in the long term, it's it's immensely interesting for application level, knowing that that data is non-volatile.
Hey, I'm just some guy sitting at home, and I don't know what the heck 3D Crosspoint is.
Well, none of us do because Intel refuses to talk about it.
Well, we say a little
we've
bit.
got some ideas.
Is a new technology coming out from Intel Micron, which is a non-volatile storage, bit addressable. It's got 1,000 times the performance of flash. It's got 10x the endurance of flash. It's got 1,000 times the density of DRAM. So in the space of
And a price point somewhere between.
no one knows what
Well,
the price point is.
I got that it's somewhere between flash
And DRAM.
And DRAM.
Well, how about
Yeah,
it
that's the
has
only-
to be because otherwise it's not going to ever exist.
Okay,
Yeah,
all right.
yeah,
Right.
yeah.
And-
But well, there is, if you think about the existing NVDIMM market, which granted isn't very big, that costs 3 times as much as regular DRAM. And so
there's a
they can
spot there
start
for this,
they can start ramping up their production and getting their costs down by replacing that.
The challenge
what-
with 3DX is that it can be both a memory as well as a storage structure. It's going to come out in SSDs.
Now, how
Will
much
be
would you
both.
pay?
So it almost reminds me of the memristor. Are we going back there?
Well,
It is
no,
a memristor.
actually, it
It's
is
a
a memristor.
memristor
It is a
competitor,
memristor,
but it's something that actually people are talking about delivering.
And unlike
And
the
there's a
memristor,
standard.
it actually exists.
And it
ready
actually
to
is
come
a
out.
memristor because so DRAM and flash store ones and zeros by charge. 3D Crosspoint and memristors and phase change memory, which 3D Crosspoint looks a lot like, but
But it's
Intel
not.
swears it isn't, store a bit as a resistance.
Okay.
So for 1 bit, it's either a high resistance state or a low resistance state. And
So is that a caching tier for a storage array, or is it something you put in a hypervisor?
Well, you're
Yeah.
just jumping to what you're going to
Yeah.
use it for. Yeah.
That seems
Well,
more
Maybe.
interesting
I
than
think
just
the answer
nerd.
is
So-
the
well, so when I-
applications are potentially endless.
It depends on price.
When I talked to them today, the answer I got was that we're not going to try to predict what people are going to do with it. We're just going to
Throw it out there, give it wings.
Throw it out
Yeah.
there.
But they're
They did not say give it away.
But they're modifying the BIOS to support it as a memory structure. They've got Optane
Right.
SSD
Right.
level structures out there. They're pushing NVMe as the interface to SSD so that they have a high performing interface to the thing. They're covering all ground here. with this thing.
Yeah, because the technology, the way that the silicon is arranged is patently different. It is, and when they say 3D Crosspoint, they truly mean 3D.
So is it stackable?
It's not stackable in multiple
3 layers,
devices.
or 2 layers,
yeah,
right?
It's stacked on
one
silicon layer.
one
Yeah.
cell is multiple layers.
Layers, okay.
And the point where the resistance change occurs is at the boundary of 2 of the layers.
Yeah.
which
and
means
you
we
can address
vastly
any
increase.
cell.
And you can right. So like DRAM, you can address any bit. So if you say if SAP HANA runs
I think that's the ideal use case.
runs in memory. And today, if you run HANA and you have data that you care about, periodically HANA has to dump its data to storage.
Right.
Makes sense.
Now, if you can lose power on the HANA servers and they don't lose the memory state,
Yeah.
you eliminate all the time and effort it takes to do that dump. And now you can take an application like HANA and you can say, here's the code part. We're going to run that in DRAM because it needs to be really fast. And here's the indices to the database, and we'll keep them in DRAM because we can reconstruct them. But the data itself we'll keep in something like Crosspoint, and we'll get a 10 to 20 times performance improvement over Flash and a much greater persistence than is possible in memory today.
Yeah, but there's going to be enough. There's going to be enough price differential, at least based on my conversation today. There's going to be enough price. So this sounds like the super awesome product, right? So like everything's going to be this. And he's like, no, it's not going to. It's going to cost too much for everything.
At least initially.
The use cases are always determined by price.
Right.
Flash has been around 15 years. It wasn't until Flash got to be 100 times, only 100 times more
25
expensive
years,
than
but
disk,
yeah.
So then we have
that
3D
we started
Crosspoint.
using SSDs.
So based on what you're saying, would it be fair to assume that 3D Crosspoint is going to come in at slower speeds than DRAM?
It is.
Yes.
It
Yes.
will be
Yes.
slower.
It is.
than
It,
DRAM.
it is.
Yeah,
It
but-
is
But way faster than
a
Flash.
tenth as fast as DRAM.
Yeah.
Not a 500th as fast as DRAM
Right.
like Flash
And because
is,
it's sitting on
and it's
the-
read-write symmetrical.
Oh, okay.
Exactly, and because it's sitting on the memory bus, in one iteration it sits
Right.
on the memory bus. In another iteration, it actually sits inside the
You sound like patent
SSD.
filing. But go ahead.
So
One
you'd have to-
iteration.
Can't help myself. So in an SSD, it's going to enhance as a sizing concern, right? We're going to get far denser disks themselves.
Right.
But on memory bus, everything is much closer to the processor. And I think that, we have seen products wherein the storage layer actually loads in as if it were RAM as well. And,
Right.
and we've seen some presentations.
Well,
and stuff
I
like
mean,
that.
virtual memory.
Well, right,
is
but
that.
Does this kill NVDIMM?
I don't.
Yeah.
Well, at the point where if Crosspoint lets you build denser DIMMs that don't cost more, so
Right.
at the point where 128 gig of 3D Crosspoint costs what 16 gig of DRAM and flash and
Like, why would you
capacitor
ever
cost.
buy NVDIMMs at that point?
Exactly. So that the
would be fast.
current
NVDIMMs are dead. I want to say something
faster.
dead.
It would be faster
this
as long as they're not power problem. But yeah.
Yeah, there could still be a use for an NVDIMM,
But it becomes
if you
very
really needed that
niche.
performance.
I think the real significance of 3D Crosspoint is the fact that now you can have roughly 1/5 of memory speed in 1,000 times the density. So where you would have 128 gigs on a server, you can have 128 terabytes
Yeah.
Right.
on that server in that same space. It might cost you an arm and a leg, and probably will cost you an arm and a leg, and it'll be only a fifth
You'll
as
have
slow.
memory, yeah.
And imagine what you can do from a database perspective then.
And that's true. And another thing that we fail to think about in terms of pricing things out is a database when you don't have to divide up the discrete elements amongst servers also. If one database can run on one server, we've got a massive increase in performance.
Let me ask
on
a
that,
clear.
I'm sorry, on that point, I want to make another point here too, and that's the other thing that Intel announced today was a many-core CPU, a 22-core Xeon. What are you going to do with all those cores? Well, if you have a database if you can fit your database in RAM on the memory channel, you
Right.
could keep those cores active.
I mean,
And now you don't have to shard it across a bunch of
Yeah.
servers, and you don't have the network latency between the shards.
But doesn't
Or
that kinda go
alternatively, you
against
could just
the
have a
trend?
much larger database that is sharded still.
Which trend?
I mean, doesn't that go against the trend of wanting to distribute your application and not silo it to one server and
Yeah, I don't think
key value pairs
that
and things
trend
like
is
that?
dead. I think it just means
Sure,
we're going to have
yeah.
even bigger databases.
I'm not this guy trying to say everything's
Yeah.
dying here, but
Yeah.
I gotta.
People are
something's-
trying to make it-
Something's got to die. We got to make a prediction.
I don't think sharding a database is a trend because it's desirable. I think sharding a database is how you
necessity.
deal with large databases and current x86 servers.
Right.
So that's not a trend where somebody said this is a good idea. That's a trend where somebody said this is how I
In
can
fact, it's
solve
added
the
layers of
problem at
architecture.
hand.
Right.
Well, I'm
And
not
if we
saying
get
it's
rid of the
necessarily
problem,
a good or bad idea, but if you're running a distributed kind of architecture and alongside that you want to do metadata distribution with key value pairs, then you would just do that by the nature of your architecture, right?
Yeah,
so
but-
that's just
but-
that's a choice you're
and
making.
then we store that metadata on
all the nodes kind of thing.
Yeah, but-
not
but
just
on the
it's
3D
running as
Crosspoint
one.
is what I was.
yeah, but you're not going to run an airline reservation system or an ERP system on
Well, we all know
that
airline
kind of-
reservation systems are, anyways.
that kind of.
They're DOS-based, aren't they?
Actually, there is a special operating
series.
system for
Can I
mainframes.
ask a clarification question? Both of you used a similar term about a fifth as fast. So are we saying that it's 20% of the speed or 20% less of the speed?
20%
I think
of
latency
the
is
speed.
Okay,
slower.
all right.
And I think the number of read and writes that you can do on that, and 3D Crosspoint versus DRAM is slower correspondingly.
There's also the idea that you need to expose the feature to the application and then rewrite in some way the application to no longer worry about
But I mean,
acknowledging past that point.
But those applications
That's not a trivial
already
amount of-
use memory. And so if this is coming in as just another form of memory,
Yeah, I mean,
what are you talking about?
for
Talking
something
about making sure the application understands what it's talking to,
Yeah,
so
but-
that it's not
Yeah,
doing
well, that
kind of
was
stupid things.
One of the consistent things I heard in the second half today was that software, their thing was, okay, software, you're the bottleneck now, right? There was one chart where they showed that, like, right now, software is is, I don't know, 5% of the latency, and then they're saying as 3D Crosspoint comes out, software ends up being 80% of latency, which means people are going to have to address that.
So
right?
they had that chart. So it was an NVMe SSD, right, which had a
Right.
9 microsecond latency time, and they said 8 microseconds of that is the software controller side of that.
Right.
1 microsecond was the PCIe overhead.
Right.
So when you go to 3D Crosspoint SSDs, presumably down to a microsecond.
Yeah.
Yeah.
Whether they reach that.
And if you're talking about an application like HANA, it might actually be a simplification
Of the application architecture.
to eliminate the whole I have to dump
Checkpoints
to
and all that
storage
stuff.
and
Yeah,
checkpoints.
you take out the
It's
stuff.
just
that-
it's something that needs to be
Oh,
addressed.
no, new hardware always needs
I
software.
think this
support.
eliminates backup. Don't you think?
Really? Backup is dead? Oh, don't make me come over there.
So why would you need backup? You
Poor
have it all
Curtis.
in storage now. Why? It's all. It's there.
Just take a snapshot, Curtis. That's as good as a backup any day.
So,
It's getting dirty.
yeah, before we get into any more trouble here and any battles here, I think it's safe to say that that 3D Crosspoint is potentially
when it comes out.
when it comes
out.
it is potentially
Will be, yes.
a game changer.
It's like the Daikatana of memory.
Right.
But
If it's everything we think it is.
yeah,
Right. Well, but I mean,
there's a lot of buts.
They
here.
have played out the buzz pretty well. I mean, it was
Yeah.
at Flash Memory Summit. They talked about Optane SSDs and samples were available, but samples really aren't available yet. But he's obviously showing benchmarks with Optane quote unquote SSDs. So they've got something. someplace.
they've built 10, and
Yeah.
that's a good place to
We
start.
need thousands. So
Yeah, but
maybe millions.
I mean,
Why don't they
it's
just
been-
give them to us?
It's been 8 years now
mentioned-
since Flash
didn't get
came
yours?
into the
I got
data
mine.
center, and we're still in the modifying software to deal with Flash properly. So this is not going to be
That's not an
fast.
overnight.
One of the tidbits I got today was about them converting one of their fabs,
Right.
to be.
Well, I mean, the 3D NAND was a major conversion for their fabs to do it in one sense. And they're all, 32 layer is interesting, but quite frankly, Samsung's like 128 layers. or something.
48.
Yeah, no.
Well, the shipping product is 40.
the shipping product, but they've got some serious stuff in the pipeline.
Yeah.
So, yeah, there needs to be a grain of salt, and as John here mentioned as well, HP a few years back announced their ReRAM, and I haven't seen it yet.
No.
They stopped talking about it.
The machine. The machine.
Machine.
So much.
So,
With their own operating system.
yeah. So we still have some waiting to do, guys, before
And
this thing is
I
real.
still think it's really exciting.
But it's really exciting.
It's
no
really
matter what.
exciting, but the real key is, how long does it take Micron, because they run most of the fabs, to get the yields to the point
The
where
technology is really, really different than what they're doing
And
today.
Oh,
The chemistry is different. Everything is different.
I believe that ReRAM existed at HP, but they could never probably produce it
They
in
could-
volume at cost. I believe that 3D Crosspoint already exists. Now they're trying to figure out how to produce it in volume at cost. So for that, I think we're going to leave this there.
Yeah. But this is one company who's
And
done
this
that.
is one company who has a lot more potential
They've
to
made a
deliver
lot of
on a
silicon before.
semiconductor innovation, and so in Micron.
Yeah.
So thank you guys for this really wonderful discussion of 3D Crosspoint NVDIMM. There is more content like this if you go to the YouTube channel, youtube.com/techfieldday or techfieldday.com, or just Google this
Vimeo.
stuff. Good luck finding the answer, though. I hope that we get a good answer soon.